Now we're going to use the determinant to find the cross product. Okay, so we're going to find cross product using determinant. We are going to use the evaluating process of determinant to find the cross product. All right. So we're given two vectors, A equals to A1, A2, A3, B equals to B1, B2, B3. So the cross product, A cross B, can be written this way, okay? The top row, we're going to put the basic vector there, I, J, K. I is a typical 1, 0, 0, J is 0, 1, 0, and K is 0, 0, 1. And we'll put A1, vector A at the second row, and vector B in the third row. So simply expand this, all right? So we would simply use the word expand into 3, 2 by 2, or order 2 determinant, or evaluate the determinant, with respect to the first row. As you can see, the first row are 3 vectors, right? So we're going to have this, right? I'm going to put the vector on the back. So the first one, I will be A1, right? So for the I, you'll be cross out these two, right? So you have A2, A3, B2, B3, I, minus. So J, you cross out these two. So will be A1, A3, B1, B3, J, plus last one K. I think you're familiar with that by now. So A1, A2, B1, B1, B2, K. And then we simply write down according to the evaluation of determinant of order 2. So the first one will be A2 minus A2 B3 minus A3 B2 I minus, all right, so be A1 B3 minus A3 B1 plus A1 B2 minus A2 B1. So don't forget J and don't forget K. Or we can say this simply is a vector A1 B3 minus A3 B2, comma, all right? That will be A3 B1, which change sign, minus A1 B3, because there's a minus sign there. And A1 B2 minus A2 B1. As you can see, it's hard to remember the bottom part right here. However, if you know how to use evaluating determinant, you simply place your vectors in such order, the top row as the 3 basic vectors, second row was 1 vector, third row as the components of the other vector, then you can use the evaluating process to get the cross product, right? Let's just see an example here. How to do this. All right, find A cross B, where A is 1, 3, and 4, and B is 2, 7, and minus 5. All right. Also, show your result being orthogonal to both A and B. All right. So let's see, A cross B being, the word important, the first one had to be the second row, all right? So it's I, J, K. So that will be 1, 3, 4, and 2, 7, -4. All right, so this is equals to, let's see, 3, 4, 7 minus 4. Remember this? You cross out these two, you get the first one. So comes I minus, and now you cross out these two to get a second one. So it's 1, 4, 2 minus 4, J, and cross out these two to get the third one. So you get 1, 3, 2, 7, K. So that will be -12 minus 28, I, and wait. Sorry, that's, oh, my bad. I made a mistake. Here be -5, not 4, so that will be -5, -5, so that will be minus 15, my bad. 15 minus 28, and minus, that will be -5 minus 8, J, and plus 7 minus 6, okay. So if I write that in terms of vector form, that will be -43, 13, and 1. So that is a cross product. All right, just confirm our case, right? Let's see, is cross product, let's see, do this, -43, let's check the dot product, right? They're orthogonal. If they're orthogonal, the product should be equal to 0. So the dot product was 1, 3, and 4. As a result, that's -43 plus 39 plus 4. Obviously, that's 0. Let's try with a B. So -43, 13, 1, dot B, 2, 7, -5. What do we have? So it was -84, 86, right? Plus 7 times 13 is what? 91. And -5, obviously, it's 0 as well. So the vector A cross B is orthogonal to both A and B.